my dear students, welcome back to my class. In the series of learning programming in C, in the previous video we have discussed about the complete program on nested structure with execution. Well, in today's video we will discuss about structures and function. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Passing structure to a function can be done in two ways. One is call by value, the other one is call by reference. Call by value means we pass the actual value, whereas call by reference we pass the address. So when we say we are passing the actual value, we receive the copy of the structure. So changes that what we do in the function definition will be to the copy of the structure but not to the original structure. So changes that what we do in the function definition will not be reflected back to the place where the function was called. Whereas talking about call by reference, which is address, as we are passing the address of the structure, we receive that through a pointer. So we must know how to have a structure pointer. So we receive the address and whatever changes we do, we are pointing to the same location and doing. So it is going to reflect back to the place where the function was called. So changes that what we do with call by value will not be reflected in the function definition. Whatever changes we do, that changes will not be reflected. But because it is a copy, when I say call by value, I am passing the copy of the structure. But call by reference, I am passing the address. So when I am passing address, I point to the same location, so changes will be reflected. So how this call by value and call by reference can be used in our program? Let us see with example program. Well, in today's video, we will see call by value method. So here we go with a complete program to understand structure and function. So here we have the structure by name student. I say struct student, the structure definition part. Two members, we have two members. We call them as members, that is name and then age. The definition part is done, semicolon, and this is what the function declaration. So I have a function by name print. So this is what the function declaration. So I am declaring the function by name print. Return type of that is void, followed with the argument. Look at here, I am passing the structure variable as argument. Structure variable in the sense I am passing all the members. So I say struct student, yes. Okay. And here we go with the function definition part. So in the function definition part, so the function definition header again void print struct student yes, followed with the code of that. I am trying to print the name and age. Name percentages, I just say yes dot name, yes dot age. We'll come back to this later. Let us start from the main function. We'll come back to this function definition once again. We have the main function. Execution always starts from the main function. And we are creating the structure variable std. As soon as the compiler encounters the variable declaration statement, it is going to allocate the memory for the variable. Means to say, it is going to allocate the memory for its members. By looking into the definition part. So I am going to get the memory for name and age. Name it is 20 bytes and age it is 2 bytes. So some address will be there. Say for example, totally 22 bytes will be allocated. Say std will be having some address, say 100. In fact, the structure variable will give you the base address. So it will be acting as internal pointer. So what happens actually here? Let me tell you some more details about the structure variable. When this variable is created, it will be acting like internal pointer. Means when I say std, the variable when it gets created, it is acting like a pointer. Say for example, the address is 100. So this address 100 will be held in std. So this std is acting like internal pointer, means it is going to give the base address of the first member, I can say. Okay, so std is pointing to this location. So it is acting like internal pointer and it is holding the base address. And if I want to do some, or if I want to access some values of these members, I cannot just move this base address. I have to access through dot operator. But if I want to move to the next location, I use pointers. That we will deal in separate video. So just understand that std, that is the structure variable, is acting like internal pointer. It is like internal pointer that is holding the base address. Base address means address of the first member, right? Now, I just enter your name. I'll just say percentages std dot name. Say again std dot name. I don't use any ampersand because I am using the base address. For character array, the array name will itself give you the base address. So I just say std dot name. Then I say enter your age. Then I'll enter the age at percentage d ampersand of std dot age. Then here comes the function call. So we have the function call here. So I am calling the function print. Function call is done here. I am calling the function print. Now look at here, the argument, I am passing the structure variable. So I am passing the structure variable. Maybe it is internal pointer, but I am passing the actual value of structure. Means I am passing the copy of the structure std. So this entire data, so for example, if I've taken the value as yes and say the age as 35, so here I am sending the copy of this entire structure. The copy of this entire structure is being sent here. So this is call by value method. I am passing the actual value, that is yes and 35. That is the values of this structure, means the members value. So we have two members. One is name, the other one is age. So I am passing those entire data. So the copy of this entire structure is being sent. Now the function is invoked. The control will be to this definition part. So in the definition part, I am receiving that entire structure. So I am passing structure means I have to receive that through structure itself. I am receiving that with a new structure variable, yes. So what the compiler will do? A new structure variable is being declared, means this structure variable is receiving those values. So a memory will be allocated for yes, right? So yes will be a new location. So I am passing the actual value. I am passing the actual value means I am receiving that with a new structure variable, yes. See, the address is 200. I am getting the memory for storing those values, that is for name, and the other one is for age. So I am passing the actual value. I am receiving that with new structure variable. Just understand this point. I say std. I have accepted through std. So I just say std dot name, std dot age. I have accepted the values. Now I am calling the print function. It is not printf, it is print function. I am passing the structure variable. So I am passing the structure variable means I am passing the copy of the structure variable. When I am passing the copy of the structure variable, I have to receive that with one more structure variable. That's what I am doing here. So I am receiving that value with yes. So I am receiving that in yes, that is yes and 35 has been received. Then what I'll do, I'll try to print that. So on my output screen, I'll get name, percentage yes means yes dot name. I say yes dot name, I'll get yes. Then I say yes dot age, I'll get 35. Done. Then I'll come back to this. Then the main function ends. So here I am passing the actual value. So I am receiving that with new structure variable. That point you need to remember. I am passing the actual value, receiving that with new structure variable. So here std is different and yes is different. Std location is 100. Yes location is 200. The copy of the std is being stored in yes. So whatever changes I do with this yes will not be reflected to the std of this main function, to the place where the function was called. So what I do here, I say yes dot age equal to say 40. Okay, I'll change this. I'll say yes dot age equal to 40. If I print that here itself in this function definition, well, I'll get that. But what I'll do, I'll come and print in the main function. The control is back to this after executing this complete function. So here what I'll do, I'll say printf new age equal to percentage d, Then I say std.age. std.age. Look at here. So what I'm doing, I just change the value here. I say yes.age. What's the value I've given? I'll say 40. So this is the change that what I'm doing in the copy of the structure. That is in yes. I'll come back to my main function. I'll say print that new age, std.age. Is that going to be reflected? No. std is different, yes is different. The copy of the structure is being, the values of the structure is being copied to this new structure, yes. So if I do the changes in this new structure, it is to that new structure, that's a new variable, yes. And when I come back to my main function and if I try to print std.age, I am going to get 35 itself. Got it? So my output will be like this. I'll accept the values. I'll say accept yes and I'll accept say initial value say 35. Okay. So I'll print that also. Then later I'll change it. Then I'll come back to this. I'll say new age. New age. Print std.age. New age. So what is that? New age. std.age. It is still 35 itself, not 40. Because the changes that what I did was to s, not for std. That's what I said. Changes that what I do in the function definition will not be reflected to the place where the function was called. So when I come back to my main function, here if I just try to print that value, no, the changes will not be reflected. This is what the drawback when I pass the structure as call by value method. So let us see the complete execution of this and we will see how we'll get all these values. And in the next session, we will see the call by reference method. So here we have the program to understand how to pass a structure to a function. So here we have the structure definition. So here we have the structure definition, the structure name student, two data members, name and age, and we have the function declared as print. And just observe the argument, we are passing the structure as argument. So we say struct student with the structure variable yes. This is what the declaration, this is the declaration part of the function. This is the declaration part. And here in the definition part, what we are doing, we are trying to print the name and age of the student and I am passing the structure variable as argument. So in the main function, we have the variable std. When I say enter the name, std.name and std.age, then we are calling the function. This is a function call. Say print std means I am passing the copy of the structure std. So I am receiving that with the new variable yes and I am printing that. So if I just execute this, I am going to just accept the value and I am going to print. But whatever changes I do in this definition part will not be affected here. So in the main function, if I just come and print that new value, that will not be affected. So let me run this program first. So save this, run the program. So here we need to enter the name and age. So from the main function, we are accepting the value for name and age. So we have to enter the name. So let me enter the name, say Yashoda, enter the age, say 35. Now look at here. So I'm going to get this. So I'm passing the complete structure print yesterday. So I'm calling print yesterday. So it will go to the function. So I'm passing the copy of the entire structure. I'm receiving that with a new structure variable yes and I'm printing that. So what I'll do here in the function definition, I'll say s.age equal to say 45. So I'm changing this. And when I come back to the main function and if I try to print that new age, you will not get that. So I just say new age equal to percentage %d. Then I say std dot age. So well, I did the changes in yes.age, but now here I am trying to print with std.age. So it is the changes that what I did here, right? So if I just execute this, so let us see the changes. Is that 45 change reflected here also? Let us see. So enter the name, say yes, then enter the age, say 35. Look at the output. So I get
Name equal to Yash, age equal to 35. The age that what I change in this function definition part is not reflected. When I come back to the main function, new age is the same thing, it is 35. So this is the drawback when I pass the structure as argument but with call by value method. So this is call by value method where I pass the actual value itself. Changes done in the function definition will not be reflected back. So this is the drawback when I pass the entire structure with call by value method. So hope you have understood with this. The next coming video we will see how to pass the complete structure with pass by reference. That is call by reference method. So in the next video, till then take care. Bye bye.